Today we're going to start our rock investigation with a rock type called Igneous Rocks. And I've got a picture up here to kind of clue you in on how igneous rocks are formed. Hopefully you can see some molten rock here, both under the crust and on the surface. That's really what I want you to think about when you hear the word igneous, is I immediately want you to get this picture in your head, because molten rock is really what forms this rock type, igneous rocks. Okay, and we've been talking a lot about two kinds of igneous rocks already in our tectonics unit: basalt here and granite here. Both igneous rocks formed from molten rock, but formed a little bit differently, and we can tell their formation, how they formed, by looking at some features about them. So we can see that they do look different, and those clues we can use again to figure out where they came from. So that's going to be our real focus of the day here. Igneous rocks, how they formed, and what features tell us about how they formed. Now, we always start with some essential questions, things we do want to know at the end of our discussion in here. So we want to be talking about how do we create an igneous rock? What are those steps needed? We also want to know what are some differences between the two main types of igneous rocks, which are intrusive and extrusive. Hopefully you'll have a good handle on those definitions as we wrap up today. And then we want to be able to write a little history sentence about how that rock came to be. Okay, and that will be evident from looking at the lab today. We are going to look at the rocks and figure a little bit about them. Okay, so for starters, how are we getting this igneous rock? What has to happen in order to make it? Well, we've got two ways that this can happen. Igneous rocks are going to form when molten rock or liquid rock has to cool. Okay, when this molten or liquid rock is formed, it's not an official rock until it goes through cooling and crystallizing. Cools and crystallizes, and this is basically our fancy science word for cools, right? Crystals form to make the rock happen, and we see that happening down here underneath the earth. Here's a picture of a few little crystals growing as that magma starts to cool. So we've got this molten liquid rock deep inside the earth. Once it cools and crystallizes and becomes a solid, that's when it really becomes that igneous rock. So that's one way that an igneous rock can form. A second way is very similar, starting out with molten or liquid rock, but now instead of happening inside the earth in that magma chamber, what we have here is the rock, the molten erupts. Okay, and of course when it erupts, it's coming out of a volcano, coming out of the earth, and again, it won't officially become that rock until it crystallizes. So that is an important piece in our igneous rock puzzle. We go from molten rock, hot, liquid, melted rock, into a solid that we say cools and crystallizes. It doesn't officially become that rock until the crystallization happens. Okay, and now we can see here lava happening on the surface, right? We see the people up here overlooking this lava flow on the surface. Okay, so we've talked a little bit about magma and lava. We want to make sure we know the difference between the two. Now I have this text up here in blue to just kind of give you a little heads up. This is something happening on the right side of your paper. So if you take a look on the right side of our notes there, we've got a little space to talk about the difference between magma and lava. Just look at this image here. Okay, we can see magma labeled here, lava labeled here. We should notice a similarity. They are both molten rock. They're both melted. But their location is a little bit different. Obviously here we see the magma is underground. So we define magma as molten rock underground. And again, lava up top here, still molten. Still molten rock, but it's simply the location that changes the term. So molten rock on Earth's surface. Same composition, just as soon as that magma hits the volcano and comes out onto the Earth's surface, it immediately becomes the term lava. So magma, lava, both molten rock, but the location is what defines it. Now this is kind of a nice picture to maybe add into your notes. Go ahead and pause the video and just do a little sketch here showing a labeled magma chamber underneath the ground and a labeled lava eruption on the Earth's surface. That's going to come in handy a little bit later in the unit. Okay, now once we start working towards these rocks classifications, the main thing that we're going to focus on here is the rock texture. And when we talk about texture for igneous rocks, we have to be careful. We are not talking about how the rock feels. Okay, feeling a rock isn't really going to clue us in terms of igneous. What we're looking at here is the grain size. And when we say grain size, we're looking at how big the crystals are. Okay, we want to see, can I see the crystals in the rock or not? And that grain size is really going to tell us two things. It's going to tell us the origin of where the rock cooled, as well as how fast it cools. Okay, so it really tells us where the rock came from and how fast it became a rock from that molten state. That's pretty cool. The other thing it's going to clue us into is how much gas is trapped inside the magma. So was there a lot of gas present in the volcano or not a lot? And that clue again is going to tell us how the rock came to be. So as we talk about texture, again we're thinking about grain size. So it's all about how the rock looks. Okay, it's the size of the crystal that's going to give us the information. The size of the crystal is going to tell us how the rock cooled and crystallized. Okay, again, super important. I would star, highlight. I have this in bold. It's important for a reason. Texture is not telling me about how the rock feels. You kind of got to push that out of your brain for this unit. Hello. Okay, it's not telling me how the rock feels. Feeling the rock isn't going to do anything for me here. I have to look at the grain size. And so we see two opposite ends of the grain spectrum here. Here is my fine-grained, small, and my coarse-grained, large. And just looking at it, we can see the coarse grains over here, right? These are the large grains. I can see the different pieces of the rock, the different minerals that are present. I can see the different colors, and if you were holding this rock in your hand, you'd see them reflect in the light. But over here, the fine grain, it looks pretty consistent, right? It's all one uniform color. I don't notice the little teeny tiny grains. I would if I had a microscope, but with my naked eye, I don't really notice the definition that I do over here. And so that's the big difference between the fine grained and the coarse grained. Okay, so as we talk about these, we're going to notice that there are some coarse-grained rocks. Okay, and that coarse texture, we could also say large or big crystals. Now, these crystals are that way because of how the rock cooled. And we know when there are large crystals present, that means that the rock cooled slowly, so it tells us about the speed. And it also tells us that this rock then formed inside the earth. Okay, so again, take a second, get an image of what a coarse-grained rock looks like drawn in on your paper. Just draw a little rock outline, nothing fancy, but then put in a few crystals, right, that can be seen and kind of shade them in so you get that idea that, oh, I can see the different pieces within this rock. With my naked eye, I don't need a microscope. Okay, so these coarse grains, whenever I see that big grain, I know those rocks were cooled inside the earth. They were cooled here, they had protection and time to grow those larger crystals that I can now see in the rock that I'm holding in my hand. Okay, we call these rocks intrusive. And that was one of the words we needed to know for our essential questions. Okay, these rocks are called intrusive because guess what? They cooled in the earth. Okay, it's in the name, like a lot of things we've been doing lately. The name is not meant to trick you here. These are intrusive rocks. So where do they cool? Inside the earth. Okay, intrusive rocks are what we see when we have rocks with large crystals. Okay, so knowing one type of rock is going to be intrusive, guess what our other rock type is? We have the other type of igneous rocks where they're not cooling inside the earth, but they are cooling here on the earth's surface. Okay, these type of rocks have a fine texture or small crystals. Okay, that was the image that we saw earlier where we can't see the individual grains here. I don't see the different colors. They are so fine-grained, I would need a microscope to look at the actual crystals that have formed here. So again, pause the video, right? Draw in a little rock shape and just make some tiny little dots. They're very small, right? Or just shade it in all one consistent color. That's what we notice here in the fine-grained rocks. Now they are fine-grained because they cooled quickly. Notice it's the opposite of the other one, right? They cooled quickly, and they cooled quickly on the Earth's surface. Right? And that makes sense. This is thousands of degrees down here. We're talking like 4,000 degree molten rock, all of a sudden, boom, right here on the 60-degree surface. It is instantly going to harden into that igneous rock on top. So we get a quick cool, and because it's cooling quickly, I don't have time to grow those beautiful crystals I saw on the other one, right? I don't have time to make that coarse grained. It's cooling instantly, very quickly. I'm going to get this nice, consistent color, very teeny tiny fine grains, again from cooling on the Earth's surface. Okay, we call these rocks then extrusive. Okay, because they are cooling on Earth's surface. And again, there's a hint in the name, right? Extrusive. It's like exiting. Okay, so the rocks have exited from the earth. They are out on the surface. You can see the lava flow here on the surface. They have exited from the inside of the earth, so we call them extrusive rocks. Okay, so let's make a connection. Stop and think. What do we know now about intrusive and extrusive rocks paired with magma and lava? Take a second and circle this on your right side. Here we got the blue text again. Circle this on the right side. If it is officially an intrusive rock, would it be cooling magma or cooling lava? Same question down here for extrusive. Think about where it's forming and where I would find each of those things. Okay, so circle up. Intrusive rocks, are they magma or lava? Extrusive rocks, magma or lava. Circle it up. Now that gets us to the back side of the paper here. This is our lab portion of the rocks unit, where we're just going to take a quick peek at 4 different igneous rocks, make a quick observation, look at their crystals, and start to piece together where did they form and what was their cooling rate. Was it fast or was it slow? So you've got 4 rocks that you're going to look at, and you're going to observe 5 different things about them. Now I'm going to recommend that you start here, put a star at this one, because what I want you to do here is tell me what you think the rock looks like. So as you come across each rock, maybe give something about its color, maybe something about it reminds you of, okay, just an observation. What do you notice? Okay, once you have that done, you're going to start in by looking at if it's fine-grained or coarse-grained. Okay, and you're going to start thinking about where it came from based on that material. Okay, so here's what our first rock is going to look like. It's going to be granite. Okay, so granite, we can kind of start to get a vision here, looking back at our sample, looking back in the video. Is this going to be fine-grained or is it going to be coarse-grained? Okay, knowing that piece of information, I've got to then go through and fill out my chart. Here are my word choices for each of the 4 columns. So I'm going to use these terms in each of the columns. No other words allowed. Once I have my observation and I've decided with my group here, is it fine-grained or coarse-grained, I've got to choose, is it lava or magma? depending on the grain size. And if it was lava or magma, would that officially be an intrusive or an extrusive rock? Okay, so again, you are choosing from one of these terms. Now here, the process, you can go ahead and actually fill that whole thing in right now, because there's only really one way this rock can form. It has to go from the molten material and cool and crystallize. So that's going to be repetitive in each of those rocks. But again, the last one, we've got to make a choice. Depending on how we filled in the rest of the columns, did this form beneath the earth crust or on the surface? And again, this should match up with your other terms that you've chosen here. Okay, so get those rocks, check them out, give a quick description, what does it look like to you, and then go back and do the classification and the features. Where did it come from? What did it form from? And that's going to get us through all 4 rocks: basalt and rhyolite. Once those are done, you're back to your essential questions. Okay, give me a describe. Where are these igneous rocks coming from? How are they created? Look back in your notes, look back in the video. Describe, give me a difference between intrusive and extrusive rocks, so define each one. And then finally, write in 2 history sentences using your lab chart. Okay, so pick 2 rocks to explain, and you're just going to read your chart. From left to right. Okay, so you're going to say this rock was from lava or magma. It then intruded or extruded by cooling and crystallizing beneath the Earth's surface or on the surface, and it formed granite. So again, you're just going to go through that list, putting in the words that you use. So put all 5 of your boxes into one sentence. This rock type is from lava in this location. It cooled and crystallized here to make granite. And again, pick 2 rocks, so you might have a different one than your neighbor. There's 4 here. I'd like you to do 2. As you do the rocks, please make sure you get them back to their right location.